American Cleaning Institute estimates that Americans spend about 5 to 6 hours every week just on household cleaning. That's time that I feel all of us have felt slip away. Vertical surfaces, whiteboards, windows, walls can be just as demanding to clean as floors. However, unlike floors, there's never been an autonomous, compact solution to clean them. Until now. Introducing the E-Raser, an autonomous robot designed to clean vertical surfaces easily and hands-free.
Hi, my name is Nithya. I'm a student at MC and I'm on the hardware and CAD designing team for our project.
My name is Ricardo Palacios. I went to Seneca Valley and I'm attending MC through the early college dual enrollment. And I'm part of the hardware and CAD team on my project.
Hi, my name is Zoe. I go to Montgomery Blair High School and I'm working on communications and part of the software team.
Hi, I'm Emily. I go to Montgomery Blair High School and I'm the software lead and I also help with design.
And our project is the E-Raser. The E-Raser is essentially a whiteboard cleaning system which works through an attachment to an eraser, which will be able to move around a whiteboard using the help of a Raspberry Pi camera to automatically clean whiteboards or most smooth surfaces using a design inspired by Micro Mouse, which is a race competition based in engineering. So what's exciting is the prospect of using a fan, also inspired by Micro Mouse competitions, which use a fan to suction to the maze. Imagine using a fan to suction to the whiteboard, and while keeping the weight down, being able to move around in that form factor. Once we get all our materials, we plan to split up between the hardware and software side. Me and Nitya plan to work on the eraser itself, and they two will work on the software side and also the camera aspect of connectivity.
We recently got the parts we requested to print, 3D printed, and we were able to assemble 2 of them. And right now we're just working on adjusting the dimensions so they fit better and that the parts are less fragile.
So in this prototype, we have the main chassis, which on the bottom, if you can see here, we have just some electrical tape in an attempt to have a tighter seal because we want as little air as possible to be able to enter in from here. Through here, we have an impeller, which will essentially suck out the energy and shoot it out the sides, right? So that's why this is open up here. And then we just have the motor sticking out from the top, and then we have this holder here. That's the essential system that we'll have, and we'll have a bunch of battery motors here. We have the CAD model here. We have essentially like a blank slate for us to attach everything. So it'll be relatively easy to have everything attached on here, especially with the components, the very small components that we have. We plan on one day, soldering all the components, wiring them all up. We have this simple algorithm that's able to just detect the brightest thing in the area. So we plan to use this IR camera, have it set to IR. And then we have IR stickers downstairs, which will be attached to the mouse, and then we'll tell where the mouse is. And then we're hoping to just simply direct it to another coordinate on the screen.
I also have a code that detects the actual border of the whiteboard. So we start with this picture for now, which is just a picture and we're trying to detect the whiteboard. So then we change it into grayscale. So then now it's black and white only. Then we just get the rectangle in the middle. And at the end we have a little rectangle that's around the whiteboard.
We've thought about marketing a bit, and we've kind of realized that a whiteboard cleaner might not actually be that appealing for most people. It's not a very big problem. So we've kind of changed it to being more of just a vertical surface cleaner. But for now, we're still only going to test it on a whiteboard because that's just easiest and that's what we can do in the time we have.
As parts arrive, we will do some pretty rigorous testing on the suction, make sure that works, and rigorous testing on getting the spacing between the surface of the board and the wheels. Other than that, we'll continue working on the software and hopefully get that finished pretty soon. This week I've made the wire harness, and this is just it attached to our chassis that we've made. So all that's left on this end is to just connect the motors basically and program them. And then from there, we'll just be able to connect them with the Raspberry Pi, which is connected to the little camera box over there. So we plan to use some mix of accelerometers and gyroscopes to be able to tell which orientation it's facing. And then from there, we'll essentially just use tank steering since it's just got 2 wheels. We'll have it programmed to just move 90 degrees, so it'll just be like an X, Y type of thing.
I mean, on the software side, we're just hopefully be able to implement the actual whiteboard detection into our app so that it's based on your camera webcam rather than just like one image. And then in the end, we'll have to connect it with the hardware and hopefully the pathfinding and everything works.
Last Friday, we tested the suction. And what ended up happening was it was able to hold on to the board, however, it just slowly slid down. Our main theory is that the seal on the bottom wasn't good enough, and that would take many iterations and a lot of time to figure out. So in order to have something presentable on double day, we decided to just switch to magnets. It works essentially the same, except we just don't spin up the motor, and it's just the magnet on the other side, so. All that's left now is basically just connect all the different programs that we've built. Like we have one for detecting the mouse, one for detecting text, one for detecting the whiteboard. Basically just connecting all of those into the Raspberry Pi, and then from there just attach it onto the whiteboard, and then yeah.
Basically just combining all of the software that we have and implementing it into the website and then also the mouse and just connecting everything.
We've definitely had to compromise in a lot of places, considering that all our parts came in like week 3. We've had to assemble this whole thing like in 2 weeks. So, I mean, I'm happy with what we've made in this time, but yeah.
Hello, my name is Ricardo, and this is the E-Raser. The E-Raser is a compact and autonomous solution for spaces tight or wide. Imagine a Roomba, but for vertical surfaces. Hands-free operation means you just set it and you let it clean. And with a remote control website, you have the option to guide your mouse yourself or to clean anywhere.
For the hardware of our robot, we have a main chassis, which is 3D printed as to make it as lightweight as possible, a magnet to stick to the whiteboard surface, and wheels to move across the whiteboard. For the technology, we have a separate box that's positioned in front of the whiteboard with an infrared camera and a normal camera.
To summarize, right now the E-Raser has been developed for whiteboards and smooth surfaces. However, in the future, we want to make it able to move on uneven surfaces, round corners, change from magnets to suction, and include a cleaning spray. We will need funding to improve the capabilities of our device, and any support is greatly appreciated. Thank you.